Okay, so I'm going to be doing a question here for 24 on logarithms. And so it's asking us to write this expression as a single logarithm. So right now we have 2, and then we have this constant. And so you're going to be using the log rules, which are at the very bottom um, of the exam. And I'll just quickly go to them right now. So they're here. Log rules that we're going to be using to solve this. So the main two that we're going to be using are these. These are most probably used the most, or rather these three. And then also we're going to see this one as well after later on. But so first is that if you have two products that are multiplied by each other, you could write that log of some base as that same base of one plus the same base of the other. And the second one here is that if you have two things that are being divided by one another, that's the same thing as writing it as the difference of that same base of those two things. So those are the first kind of few steps that we're going to use. So if we have this first logarithm, we have a log base 5 of x minus 7. First thing we're going to do is that if I ever have anything in front of the logarithm, I want to take it and move it to the top. So that was another one of the rules that was seen there, is that anything that you have, for example, if you have log base, I don't know, 9x squared, this is the same thing as just taking this exponent and bringing it to the front. So that means the opposite is also true. So that if you have something that's in the front, like the 2, log base 9 of x, you could also bring this up just like as you have on the left side here. So that's what we're going to do first. And you need to do this before you can do any of the addition or subtraction rules. So this is the first thing we're going to do, and we'll get log base 5 of x minus 7 to the power of a. And then for the second term, which is the 2/3 log base 5 of w, 2 over 3 are the 2/3 what you have in front that we need to get rid of as well. So just like before, we're going to bring that and take it to the front. So I'm going to have minus log base 5 of w to the 2/3 power. And now we can use that log rule that we saw at the bottom, which is that if you have two logarithms of the same base, so 5 and 5, you can end up rewriting this as a single logarithm, which is the goal that we want to do here. But you'll do one, whatever you have on one is if it's being subtracted from the other, you're taking what you have here and you're dividing it by what you have on the other one. So for example, here you would have the logarithm base 5 of, on the top, x minus 7 to the power of a divided by w to the 2/3 power. And so that's your first step. And then lastly, we have this 2, which is a bit tricky to deal with. So we have always plus 2, and it asks us to write this as a single logarithm. And right now I do have one logarithm here, but I still have this part that I have to deal with because the 2 isn't written as a logarithm right now. And so there's like a small trick for this. So if you have 2, you could say, like everyone would agree that 2 times 1 is the same as 2. So you're going to be exploiting this 1 or using this 1 as a way of writing it as a logarithm. So if you go back down here, one of the logarithm rules is that anything like anything, so log base b of b is always going to be 1. So if you go back up here, for example, log base 5 of 5 is going to be 1. And the reason why it's 1 is because a logarithm is asking you, if you have a base 5, that's saying 5 to what power gives you 5. So 5 to the power 1 gives you 5. So that's why the answer is always 1. Same thing is true if you have like log base 9 of 9. 9 to what power gives you 9? 1. So log to anything, that's why they wrote it down there, log of b is always going to be 1. So because that's true, and because we're using logarithm base 5 over here, it's going to be useful to use also, instead of writing this as 1, we could say this is just 2 times log base 5 of 5, and put that there. So I'm going to do that, and just take this up here. That's just log base 5 of 5. And just like what we did before we use these addition and subtraction rules, we need to move anything that's in front of the logarithm and bring it to the exponent of what's inside of the logarithm. So that's going to be, this term here will be written as log base 5 of 5 squared. And now I'm going to take this, bring it up. And now the last thing that we have to do is use the addition rule, which was the opposite of when we had done this rule here, where if we subtract two logarithms, we take what's on the side inside both of them, and we're dividing them from one another. But in this rule, we're taking these two logarithms, so we have this one here and this one here, and you're multiplying them together, the insides together. So the final answer to write this is one single logarithm will be log base 5. We have from the first one x minus 7 times a divided by w over 2/3 multiplied by 5 squared. And so that's your final answer for the first part. And now we can move on to the second one, which is a bit trickier. And it tells you that you have h squared plus k squared is equal to 23 hk. And we want to show that logarithm of h plus k over 5 is equal to half logarithm of h plus logarithm of k. So I'm going to take this left-hand side, and I'm going to try and show that this is equal to the right-hand side. Or you could do it the other way around, but this is just the way that I'm going to do it. Just taking the left-hand side, I'm going to try and show that this is the right-hand side. So the first thing I'm going to do is I notice that on our right side, I have two terms here, whereas on the left, I only have one. So it's going to be useful for me to use one of those log rules to split this single log back into two logarithms. And because these two are being divided by one another, the h plus k and the 5, I could say as my first step, I'll write this as logarithm of h plus k minus the logarithm of 5. It's going to be equal to all that, which is still over here. So log is h, log of h rather, and then log of k. And we are told we have now an h plus k here, but I don't know really how to move on from here because it doesn't give us any information on h plus k. But we can try and figure that out from here because they also give us that h squared plus k squared is 23 hk. So one thing that would be incorrect to do is to say, well, if I want h plus k, I could just take the square root of all of this. And this would be incorrect because you cannot take the square root and then square these two terms. When you're taking the square root, you're taking the square root of the whole thing it's considered of itself. So this will not be equal to h squared, or sorry, h plus k if you take the square root of both sides. So what I would want though is that if I want to take the square root of h plus k squared, this is what I would need to take the square root of. So if I had h plus k all squared together, the square root is being applied to the whole thing considered of itself, not just the h and the k on its own. So then these would cancel out. And so if I knew what h plus k was, or h plus k squared was, then I could find h plus k. So that's going to be basically my goal here, is to find what is h plus k all squared. And if we were to expand this, this would be h squared plus 2hk plus k squared. And that's really close to what you have already here. So you have the h squared and the k squared. So if I want this h plus k all squared, I need to add just a 2hk on this side. And if I do that, I have to also add a 2hk on the other side. So I could say, therefore, h squared plus 2hk plus k squared, taken from what we had here, will be equal to 23hk plus another 2hk. And as you saw just here, this left-hand side is just equal to h plus k squared. So this is h plus k all squared, which is equal to 23hk plus 2hk, or 25hk. So If I take the square root of all of this, that will cancel out. And now say h plus k is equal to the square root of the right-hand side, which would be the square root of 25 times hk. And when you're doing the square root of things that are multiplied beside times one another, you could split this into its parts. So I could say this is the same thing as 25 square root of 25 times the square root of hk is equal to h plus k, and the square root of 25 is equal to 5. So our final answer here is that h plus k is 5 times the square root of h times k. So we did all of that work, and now I can plug this expression, or this expression here, into the h plus k. So I'm going to do that, and we'll see that if I sort of divide this up down here now, logarithm of 5 square root hk minus logarithm of 5 is going to be equal to, I'm just going to put 2 lines to say that's the same thing. And then another one of the rules that we had saw at the bottom of the page was that if you have two things that are multiplied beside each other or times one another inside of a logarithm, that's the same thing as doing each part separately. So this is equal to logarithm of 5 plus logarithm of the square root of hk minus logarithm of 5, and that's equal to the same thing. But we have logarithm of 5 minus logarithm of 5, so that's gone. So then I have that the logarithm of the square root of hk is equal to what we had over here. And a square root is the same thing as the power of a half. So we'll write it like this. And then again, another log rule was that any exponent can be brought to the front. So this exponent of a half can be brought to the front, and I'll get 1/2 logarithm of h times k is equal to, and we're getting very close now because it's looking quite similar, is equal to half the logarithm of h plus the logarithm of k. And then the final logarithm rule again that we're going to use is that, again, if two things are multiplied by each other, that's the same thing as adding them together and splitting them up into separate logarithms, which is the final step. So we'll see that half on the outside is being multiplied by logarithm h plus logarithm k. So the left-hand side is equal to the right-hand side. So we've shown that proof there. Okay, and then we have more left-hand side and right side proofs. So these are now just trigonometry. So you can again choose whatever side that you want to move on, start on, and then move to the other side. I'm just going to follow the same idea of just taking the left-hand side, and I'm going to show that it's equal to the right. So if I have cosine theta plus sine theta, I want to show that it's equal to 1 plus tangent theta over secant theta. And just as a reminder, secant theta is equal to 1 divided by cosine theta. So I see here, I see here that I have something divided by cosine theta on the right, and that everything here is written under one denominator. So instead of writing this as what I have here, I can divide both of these terms by something. So I'm going to divide it by cosine, because I see that I have like a 1 here. So if I divide this both by cosine theta and cosine theta, I already see that I get kind of close to what we have on the top here. I get 1 from this term, cosine divided by cosine is 1, plus sine divided by cosine is tangent theta. Still supposed to be equal to 1 plus tan theta.